from Michigan State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenter today Dr. Nicholas Horton, who is a professor of statistics at Amherst College. For today's webinar, he will give a presentation entitled Data Science for Undergraduates, Opportunities and Options. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give the presenter a chance to respond. You can also use the chat box if you are having any technical questions. At this point, I'll turn things over to Dr. Horton. Nick, go ahead.
Great. Well, thank you very much to Cause and the two of you for helping to structure things today. I'm really excited to be talking about the recently released consensus study on data science for undergraduates that was put together by the National Academy of Sciences. I've given the link on the bottom of this slide and many of the other slides of this presentation that allows you to set up an account and then download the report for free. My goal today is to try to really give an overview of the report, what I think is helpful for us as the statistics community, and to try to figure out ways to engage in the growth of data science that we're seeing nationally. So just a quick overview, no surprise here. Our economy, society, and daily life have become increasingly dependent on data. And new college graduates who are entering the workforce need to have appropriate skills to analyze data. The study really explored the questions about what data science skills are really essential now for undergraduates, what will be true in the future, and how academic institutions can really structure these programs to best meet those student needs. The group met for about 2 years. We released an interim report last fall, and the final report was released earlier this summer. The committee was ably led by Laura Haas. She's the new Dean of Data Science at the University of Massachusetts Amherst, and Al Hero from the University of Michigan, who's also the chair of the Committee on Applied and Theoretical Statistics. And again, a really wonderful group of people from a variety of disciplines who labored over those 2 years to really bring this together. I also want to single out both the groups behind this at the National Academies, and in particular, Michelle Schwabe, who's the study director from the Board of Mathematical Sciences and Analytics, and then Linda Casola, who did a tremendous amount of work as editor of the report. And again, a lot of this really wouldn't have happened without their efforts. As a way of getting additional feedback from the various communities that were involved, the study elicited a series of webinars on a variety of topics that I think are really important. We've seen a lot of Cause webinars on a lot of these different topics over the years, but to really focus on what they're looking at with, again, the same Cause focus on undergraduate education. So questions about building data acumen. This is a term we'll hear a lot in the report. Thinking about real-world applications, important issues of faculty development, how we can be thinking about teaching teamwork. Interdepartmental collaborations are really important because data science really doesn't fit in just one place. And ethics were topics that we included in those webinars. And then we closed with 3 webinars at the end of that series on assessment, which I think is critically important to build in early and to really be rethinking. The importance of diversity and inclusion in terms of participation in data science to avoid some of the problems that we've seen historically in some fields, and really exploring the important role that 2-year colleges play. We've had the recent 2-year college data science summit, and that's also something that's really mentioned in the envisioning report. The final report contents were structured into really 4 chapters that had a lot of focused areas on knowledge, data science education, advice on starting data science programs and evolution and evaluation, as well as some beginning and closing matter and a number of very useful appendices. The report in general, I would like to kind of devote more time to discussion than to kind of going into specifics, but I did want to spend a little time giving some more background. Obviously, anytime we envision the future is hard. As a motivation, we really tried to take a utopian point of view. We've seen a lot, really in the last couple of months in particular, about more dystopian aspects of data issues, privacy issues, and the like. But we really wanted to be thinking about if we were able to roll this out in a more appropriate manner, ways that we could be really providing more aspirational sense for things. So we really want to think about a world in which every undergraduate student has some knowledge of the basics of data science, that they've developed at least rudimentary data acumen. We're assuming, and I think there's a lot of data to support this, that data science jobs of various types are going to be ubiquitous. You know, we're going to be thinking about these in all industries and all geographies. We're going to be thinking about data sciences being diverse demographically, that there you know, really all groups being fairly represented and educationally. We anticipate that the report will be highly referenced, that it will be useful for people in terms of many descriptions of needed competencies, examples of programs, and the citations and references that we pulled together. But again, throughout all this, as I said, envisioning is hard, that the recommendations are going to be evolving rapidly because the field is really evolving rapidly. So the key insights, again, no surprises here. We're at the infancy of data science. We didn't formally define data science, but we did try to describe aspects of it that were distinctive. We talk about the idea that there'll be different roles for data science in different places, and that heterogeneity is going to be something we need to account for. And they really acknowledge that data science is unique in some ways. It's not exactly the same as either statistics or computer science. And there's lots of challenges here about thinking about faculty development. So we need to be really exploring ways, again, in the way that CAUSE has really structured things, to be sharing educational resources and materials, and then to figure out what other ways that professional societies can coordinate. So at the undergraduate level, we really were saying that one of the key aspects and findings is that education is going to need to evolve very quickly, and that we need to be thinking about multiple pathways. There may be some students who get a major, who really focus primary attention on a data science program, or there may be others who study some other thing like political science or psychology, where they need to have considerable amount of data science, maybe at the level of a minor, as well as the idea that all students should get some exposure, that there could be kind of like a joy of data course or other kind of data literacy requirement that all students see. These core competencies, and we've tried to outline what these are. How do we help students develop this idea of data acumen? And really, what's the role of ethics as part of this? It's certainly something as statisticians we're familiar with, but I think there's a broader aspect of data ethics that go beyond what's typically been our research ethics focus. And then last but not least, evaluation is going to be really important. As I said, we need to be thinking about assessment and to really be making that really important and integrated early on to be able to really determine what works and what doesn't. So let me jump a little bit to the findings and recommendations. One of the things we really found is that there's going to be an increased demand for more holistic and more nuanced data science roles. So they're going to be not just one type of position that's out there where people are hiring folks at the associate's or bachelor's level with a data science degree. And so kind of thinking about how those personas, we might call them, might develop is going to be really important to think about. We're going to need to have programs that prepare different types of data scientists. There may be some that may be focused more on visualization, perhaps others that might be focused on data technologies and data technicians. But overall, our recommendation here is that academic institutions embrace data science, to really think of it as a vital new field that requires specially tailored instruction, as well as the development and support of a cadre of faculty equipped to teach. And then there really need to be multiple pathways to allow students to perhaps discover this late, to pick up some things to complement their other work. A central finding that I'll talk a little bit about are the areas that we defined as really making up data science. And this is, again, intended to be a descriptive list that would provide some guidance to people thinking about developing programs. Obviously, at the master's level or PhD level, people are going to need a lot more, and certainly there's going to be an increased focus on some other areas. But these areas that we put together, we believe are the key components of what really we define as data acumen. And I want to just take a few minutes to step through some of these as we go. This idea that mathematics is going to be important, but it's probably not going to be a kind of a 2-semester calculus focus. We need students to be able to understand some aspects of optimization and aspects of multivariate thinking, among others, but to start thinking about what these pathways might look like for programs that may not necessarily use our traditional building blocks of courses. Computation is really at the heart of data science. This aspect of algorithmic thinking and abstraction is really important. This is an area where we've taught computing in statistics a lot, an increasing amount in recent years, but there's work to be doing to kind of build a deeper foundation in computational thinking, abstraction, algorithmic thinking. Statistics obviously is a really core component of data science. There's aspects of variability, uncertainty, sampling error, and inference. And again, it's important to remember that a lot of these materials are now incorporated in the changing K-12 curriculum, and we can be thinking then of moving beyond that to include other aspects of multivariate thinking, a big part of the revised Gaze College report, aspects of design, confounding and causal inference, as well as the building blocks of exploratory data analysis, modeling, and this idea of simulations and experiments, using computation to understand better statistical concepts. So other areas that have been less traditionally focused in our curriculum, but is really important, particularly at the bachelor's level, a data scientist at the bachelor's level will likely be spending a lot of her or his time on data wrangling, data management. And so key aspects of data management and curation are important to be thinking about developing these programs. Data visualization, same kind of idea. How do we think about a cycle of data science or data analysis where there's consistency checking, exploration, some other visualizations that students would be creating as part of their programs. Data modeling, again, here's a place where historically statistics has done a fair amount, but there's a lot of new approaches with both statistical and machine learning approaches, multivariate modeling, dimension reduction, and other places where we've focused not as much, but we think are really important at the undergraduate level for data scientists. There's been an increased focus on workflow and reproducibility. We've heard a number of cause webinars on these topics of how to be bringing in these aspects for students in their work so that their work can be reproduced in some fashion, either by themselves 6 months later or by other people. These aspects of documentation and code standards to really kind of up our game scientifically. Communication and teamwork are critically important things. These are certainly important aspects of statistical practice, but we really wanted to kind of enunciate ways of eliciting questions, helping answer them, dealing with conflicts when they arise, aspects of technical writing and presentation. And then last but not least, ethics are really critical. They're needed for all data scientists, and we argue for all educated citizens to kind of be thinking about what are some of the ethical precepts for data, aspects of privacy and confidentiality in the Internet of Things age, then aspects of responsible conduct of research, identifying junk science, aspects of algorithmic bias. So these are all important things that really need to be incorporated. We had some other recommendations, really thinking about how important it is to develop a basic understanding of data science in all undergraduates, that we really do need to think about how to weave ethics into the curriculum from the beginning and throughout, and that thinking about adopting a code of ethics might be useful. Many of our professional societies, such as the American Statistical Association or the Association for Computing Machinery, have ethical statements that their members sign on to. The draft report of the envisioning study that we've been talking about included a Hippocratic oath for data science as a kind of just an idea of how some things might be looking. But this idea of having a code and to be bringing that into how we teach about data science is something that we wanted to encourage people to do. Chapter 3 really focused on the idea that data science education will be happening in a myriad ways in many different institutions. There may be introductory courses, and that may be all that people do. People could be undertaking a major program, minor programs. There could be certificates and degrees. We're already seeing a lot of growth at the associate's level in terms of data science education. Certificates might actually have fewer courses. We've seen lots of ways that massively online open courses or MOOCs can engage large number of students. Those may be less helpful for undergraduate education, but particularly helpful for faculty development. And then also aspects of what I might call co-curricular work, summer programs, boot camps, research experiences. What we really did feel in terms of the two-year college part is that there needs to be a way that four-year colleges and two-year colleges can be working together. That's a kind of a gap that we're seeing. Chapter 4 is really focused on advice for programs that we're thinking about starting data science programs, and this seems to be most universities that we've interacted with. Again, with the idea that there would be multiple pathways here, that we really need to think hard and spend a lot of effort to ensure a broader participation by historically underrepresented groups. Because again, there's lots of potential applications here, and we need to ensure that our data scientists of the future reflect the broader population in the country. That we need to be thinking about flexible course availability and structures to kind of help support and structure things so that not all the work is done at an artisan level. And then really thinking about cloud-based approaches and platforms. People no longer do computation on their laptops. Much of that has really moved to a cloud-based approach, and that's something we need to think about ways to be teaching. It's a great paper on this in the recent issue of the American Statistician, Amina Rendell and Colin Rendell about that. And again, a lot of work in the computer science world about the growth of cloud-based computing. So the evolution, kind of where we're going, proceed, obviously acknowledges there will be differences at many different institutions, that there's going to be a need to review and evolve these programs over time, and then we need to help broaden the perspective of faculty. Most of us are trained in one particular area. There's aspects of those concepts I reviewed that we may not be as comfortable with personally, we may not have taught, we may not have been taught how to teach, but we need to be really thinking about a holistic approach to data science education that can allow students to really effectively take on this ability to, as I describe it, kind of draw insights from data. We need to be thinking about lots of creative ways of supporting faculty in terms of that faculty development. And so the idea of thinking about other ways of creating websites and journals, organizations such as CAUSE that can really share best practices, what conferences might look like, how they might differ from existing conferences we have. And then closing with some of these ideas about assessment and evaluation, that ideally data science would really use data science to be able to come up to be better programs, that we need to be thinking about evaluation and assessment, really both formative and summative, and to kind of ensure that there is this aspect of continuous evaluation. So the professional societies, maybe a little less focused on this part, this webinar. I think there are good opportunities here. I think we're going to have multiple professional societies, but ways of coordinating those to really be effective in assisting both on the education and teaching side, as well as the practice of data science. And to kind of bring those kind of groups together and to really think about how best to be supporting people. That's going to be an important next step. So my goal today was to really give you a lightning overview of the, I guess, 110-page or so report, including the appendices, to really kind of think about ways that this might be relevant for us. And I'd be glad to kind of entertain questions or talk more about some of those things, but to really lay out that, by connecting to the nas.edu/envisioningds URL down here, setting up a free account with the National Academies Press, you too can download a copy of this report and start to explore ways in which undergraduate data science has many, many opportunities and options. So I'll turn things over now if there are any questions, and along with thanks to the National Science Foundation for support of this study and for the work of the committee and the staff to make it possible. Thank you.
Thank you, Nick. For those of you who are participating right now, there is a question box there. If you have some questions that you'd like Nick to answer, go ahead and type them into that question box and I will read them out to him. My question as you were going through most of this is I think about the professional societies that you were talking about at the end. Do we have something like the, ASA that's in any kind of form right now to handle this data science thing? Or are we just expecting that this professional organization will just kind of grow out of the interest that people are having in data science right now?
Well, as I said, predicting the future is hard, and
Mm-hmm.
that's definitely an aspect where it's not clear how things should be working or how they are working. I do know that the American Statistical Association and many other statistics organizations have been actively addressing ways that they are part of a broader conversation about data science. Certainly, I chaired the undergraduate guidelines group for statistics programs that the ASA endorsed back in 2014, and this is a big area that we were talking about. When we look at statistics, I think of statistics, if they're actually doing this entire cycle of understanding where the data are coming from, bringing those into some more sophisticated environment where they could be doing data wrangling, data visualization, data modeling, data assessment, model assessment, and communication. And through that iterative process that I think of really as the scientific method, I think that is, really what we're talking about in terms of a broader data science. So I know that the ASA has been involved in a lot of these initiatives. I'm also a member of the Association for Computing Machinery, which has a big focus in much of their work on these areas of data science and data science education. And I do think that there's good opportunities for us to be working across some of these existing societies and figuring out how best to be providing these structures and supports. But it's very much a wide open thing that many people are particularly interested in these areas of data science. That's combined with the fact that we have tremendous amount of data that are coming from sensor networks, from smart cities, from the internet, from all kinds of places where the flood of data is dramatic, as well as the fact that much of the costs to compute have gone down dramatically. Computational costs, particularly cloud-based ones, are trivial compared to what they were 10 years ago. And many tools exist, as an example, Python or R and RStudio, that are now open source tools that are really professional grade tools. So I think it's opened up these opportunities, and I think those are the reasons why data science is such an exciting thing. And I don't think this is a fad. I don't think this is just a kind of a blip. I think we really are in this world of data science, and it's important for statisticians to be part of that, as well as other folks from other disciplines.
So it'll be interesting to see what kind of grows out of this, I think. We do have a question from John Gaberstock. He says, Nick, what do you see as the way or format to train faculty, say someone in year 20, to get them up to speed on the computing aspects, i.e. data wrangling and such?
Yeah, so this is an area where I think there's a lot of work that we need to be doing. As I said, these new tools are out there. The folks at RStudio in particular have been remarkable about re-implementing things. Hadley Wickham has been leading up a group of people that have created something called the Tidyverse, which provides as they describe it, an opinionated set of packages that have a much cleaner interface to them. This includes aspects of tidy data, which is a way that Hadley has been enunciating a whole curriculum of data technologies that really fit very closely in the historical computational science database world. We haven't been teaching those things as much. We need to learn them. We need to teach our students them. And so we need to kind of look at approaches to be doing that at scale for our faculty. So I think this is an area. There's been some initiatives through the MAA. The Stat Prep program has been focused on bringing mostly math faculty without much of a computational background into a world where they can start to use and learn these tools. It is challenging because things are still changing very quickly, but I do think we have the potential to kind of take a step back, organize some of these materials. And again, I think this is a place where CAUSE, through conferences like US COTS and ECOTS and other entities like CAUSE can really help to provide some of that support for faculty development, because it is a major issue when we start thinking about, teaching these additional learning outcomes that people have not had as much practice with. Ideally, they will have had some practice with the statistical analysis model that really thinks about the whole part. But again, we need to move beyond just giving students CSV files as a way of kind of thinking about data in our courses, because that's not how data arise in the real world.
All right, well, again, thank you for your presentation here today, and thank you all for attending. We don't have any webinars scheduled for August, but I'm sure we'll be back in the fall with some other interesting presentations for you. So please keep an eye on your CauseWeb, on your email, and we'll keep trying to provide that kind of faculty development for all of us as we move forward in this. So thanks again, Nick, and good day to all of you.